So good afternoon. So let us start our session. I think Saurabh sir taught you some basic notions of differential equation in the previous class. So today we will start after that. Okay. So this class is taken by me, and after that, actually Saurabh sir is busy today, so that's why he can't join now. So he will take after a few classes after that. So basically, let us discuss about some things with the differential equation. Okay. So I think sir has taught you that what is a differential equation and what is a degree and power of the differential equation. Okay. So let us just discuss further that. So differential equation is what? That is an equation involving the derivatives with respect to an independent variable, and involved dependent variable is called an ordinary differential equation. OD. Okay. So now order of differential equation is what? That is the order of the highest derivatives is called the order of the differential equation. So basically in our this equation, we can easily see that there are second derivative. So we can easily show from this we can write our order of this differential equation is 2, or that is a second order differential equation. Okay. So now what is the degree of differential equation? So basically, if we write a differential equation like this, as we told that the differential equations are the equations which involve the independent variables, dependent variables, and the derivatives of that with respect to the independent variables. So basically, if we get this kind of things, so this is our ordinary this is the ordinary differential equation there. So basically from that we can write that the power of or the degree of the differential equation is what? That the degree of the highest derivative. So our highest derivative is what here? That is, we can easily see that that is our d2y by dx2. So basically the degree of that is what? That is 2 here. So the degree of this differential equation is 2. Okay. So now let us try to think about another kind of things. LDE, that means the linear differential equation. Okay. So the differential equation. So let us discuss about linear differential equation. So the differential equation is called linear if every dependent variable and its derivatives occurs in the first degree only. That means if we have a differential equation like this. So our x is the independent variable here and our y is the dependent variable here. Okay. And this is what? They are the derivatives of the dependent variable with respect to the independent variable. And we can easily see that all the degrees of the derivatives and the independent variable are all 1. Okay. So as the degrees of these are 1, so then we can just consider it as an example of linear differential equation. Okay. Now let us write another equation. So this is a non-linear differential equation. That is not linear. Why? Because we are getting a power 2 here, and we are getting multiplication here, and also we are getting a multiplication here. Okay, so that's why we cannot take this as an linear differential equation. Okay, now let us move toward the solution of differential equation. Okay, So any relation between the dependent and independent variables which substituted in the differential equation reduces it to an identity is called a solution of differential equation. Okay. So let us take an equation and let us see how can we think about that. So basically, let us take a very basic equation. Let us take our dx y by dx equals to 2y. Okay. So then from this, what can we do? We can do that our dy by y and we can take 2 dx. So basically, after that, we can just integrate the left hand side and right hand side. So from this, we will get ln y equals to 2x plus. Okay. So now from this, we will have y e to the power 2x into e to the power c, and just let us think it as c1. So basically, what are we getting now? We are getting y equal to c1 e to the power. So this is a solution. We can easily see that. So now, uh, any relation between the independent and dependent variable which substituted in differential equation, and when we are just trying to withdraw the derivative parts, then we are getting a solution. Okay. So now after that, let us think there. So there are actually three types of solution in any differential equation. So basically, the solutions are, let me write it in the screen. So the solutions are called as general solution, particular solution, and singular solution. Okay. So what is a general solution? Let us think. F y y1 y2 up to y, and let us take it as y dash y double dash dot 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 up to, and our yn means what? So our yn means what? That is only the nth derivative with respect to x. Okay. So now let us take this equals to 0. Then from this, which we are getting a solution there. So basically that is called the general solution. Okay. So just let us take an differential equation to think about this. So how can we solve that? So we have to use the auxiliary equation here. So that will give us what? So then we are basically substituting e equals to y equals to e to the power mx. Okay. So then what are we getting there? We know that our y dash is equals to m e to the power mx, and our y double dash is equals to m square e to the power mx. We know that. So after that, what can we do? So from this, we will have m square minus 3m plus 2 into e to the power mx, that is equals to 0. Okay, so we know that our e to the power mx can never be 0. So our this part has to be 0. Okay, so if this part has to be, is this part is equals to 0, we can use middle term factorization. So from this, what we will get? So from this, we are getting our, okay. So if we are getting our m equals to this, so our solution will look like what? That will be our e to the power x and e to the power 2x. So basically our general solution will look like y equals to c1 e to the power x and c2 e to the power. So basically that's how we can solve a differential equation, and we will get up to general solution. So now our particular solution is what? As we mentioned before, so particular solution is a solution obtained from a general solution by giving particular value of arbitrary constant is called particular solution. Okay, so a solution obtained from general solution by giving a particular value of arbitrary constant is called particular solution. So now let us think about singular solution. So a singular solution which cannot be obtained from any general solution by any chance or by any choice of constant is called singular solution. So let us think as, sorry. So let our y equals to x plus c whole square. Okay, that basically is the general solution of dy dx whole square minus 4y equals to 0. We can easily solve this. Okay, when we will just get some the same kind of things and the same quite same kind of approach, so we will get this kind of things basically. So we will just get our dy dx equals to 4y, then we will get 2 root y, and then we are getting this and we will get the result basically. So now we can also verify. So just a minute. Okay. So actually, what are we doing then? So then we will get here 2, then root y. So then we have to just write dy by 2 root y and that kind of, and after solving this kind of thing, so we will get this. So now we can also verify that our y equals to 0 is a solution, but y equals to 0 cannot be obtained by any choice of c. Okay, we can also verify that y equals to 0 is a solution of this, but y equals to 0 cannot be obtained by any choice of c. So our y equals to 0 is a singular solution here. Okay. Sorry.
Okay. Can I ask something?
Yes.
স্যার আমরা যে এই y is equal to 0টা কি একমাত্র সিঙ্গুলার সলিউশন হিসেবে আমরা চেক করতে পারি? মানে এই আর কি কি সিঙ্গুলার সলিউশন আমরা হতে পারি, যে কারণ আমরা তো সিঙ্গুলার সলিউশন পাওয়ার জন্য আর কোনো মেথড পাচ্ছি না।
Okay, so then I will just give you some questions, and I will also discuss some questions, and then I think the idea of this will be cleared. Okay.
Okay, sir.
স্যার
Yes.
এই ডিওয়াই ডিএক্স এর হোল স্কয়ার মাইনাস 4y এটা কি মানে y ইকুয়াল টু x প্লাস c এর হোল স্কয়ার রিপ্রেজেন্টেশন বলছে?
Hello.
হ্যাঁ, ডিওয়াই ডিএক্স এর হোল স্কয়ার মাইনাস 4y এটা কি y ইকুয়াল টু x প্লাস c এর হোল স্কয়ারের রিপ্রেজেন্টেশন বলছিল?
You can check that. No.
মানে ওটার রিপ্রেজেন্টেশন ওটা কি করে হলো?
So then I have to calculate. Okay, just remove this here, and we will so let us do it here.
आइए थोड़ा सा इधर आइए एडजस्ट करिए
So Krisanu, can you do the integration of it? Hello, Krisanu. Okay. Now I think you understood how we why I was telling this. Okay. So after that, basically, if we can also verify that our y equals to 0 is a solution, but that cannot be obtained by any choice of C. So that's why our y equals to 0 is a singular solution here. Okay. So now let us discuss something or the equations of the first order and first degree. So I just described our degree and order here. So basically, our order is what? That is the that is basically the highest derivative, the order of the highest derivative, and our degree is what? That is the degree of the highest derivative. Okay. So basically, when our degree and order both are first, so then let us see what we can do then. So a general differential equation of first order and first degree is of the form this, or m dx plus n dy equals to 0, where m and n are functions of x and y both. So now following are some standard methods to do that. So basically there are variable separation method. Okay, let me write the methods to solve. So we can use variable separation method. So basically an equation whose variables are separable and can be put in the form as, let me write it, is called an equation of a variable separable form. Now integrating that parts, basically this and this, we will get the result. So as we take something like our x square dx plus let us take uh, y dy plus y square dy equals to 0. So basically we can just remove this and we can take the common of this. So then this is the basic form, and this is an correct example of this. So if we just integrate these parts, we will get the result. Okay, and so this will be the general solution of the differential equation. So this is an example of it. Okay, so now our case 2 is what? That is equations reducible to variable separable. Now in this case, basically we will have some differential equations like and let us take it one. So now method to solve it is what? So we have to just put our equals to, then we will have, we are just differentiating with respect to x. So as we know that our x is the independent variable here, so then we are just differentiating both of the sides with respect to x. So we will get a plus b dy dx, that is equals to dz dx. Then so we are getting our dy dx is equals to 1 by b into dz dx minus. Okay, so if we are getting these things, so basically what are we getting now? So we actually are getting 1 by b dz dx minus a, that is equals to f of z. So our this equation actually now becomes this. So as this is becoming this, so what are we getting now? So dz by dx equals to then a plus bfz So which is the type of variable separable and can be solved after this. Okay, understood? So now after this thing, we will have another type of things basically, that is homogeneous equations. So so there we have to just define a thing, that is homogeneous function. So a function that is fxy is said to be homogeneous if of nth degree in x and y, when that can also be written as, or if we can put it in the form of x to the power n f of y by. So if we can just put it in this form, so then we can say that kind of functions will be homogeneous functions. So let us give an example of it. So basically our phi xy, and let us take it as x to the power 4 plus x square y square plus y to the power. So if we so then we can write it as x to the power 4 into 1 plus y square upon x square, then y to the power 4 upon x to the power. So that is what, that is basically a function of f of, that is basically a function of y by x. Okay, so that kind of functions basically are called as homogeneous functions. Okay, so now after defining this thing, so let us think about another kind of thing. So basically uh, someone wants to join. Okay, so so this is an homogeneous function, and this is an example of the homogeneous function. Okay, so now let us think about a homogeneous equation. So an equation in x and y is said to be homogeneous equation if it can be put in the form dy dx, that is equals to something this by this kind of things, where our fxy and phi xy are both homogeneous functions of the same degree in x and y. Okay, so now to solve the equation dy dx equals to this, where fxy and phi xy are both homogeneous functions of the same degree in x and y. So we have to just only do one thing here. Always keep in mind that you have to just only then we will get the result. Okay, so let me give an example of it. So let me write a question. Uh, so let us make it a third degree equation. Third degree equation. Okay. So yeah. So then let us make it as x square y, then dx for it, and our for cube we will get So if we are getting this thing, so how can we solve that? We can easily see that this is a homogeneous equation. Why? Because this has degree 3 and this has also degree 3. Okay. So now, how can we solve that? Our dy dx from it will be x square y by x cube plus y. Okay. So now let us use the Brahmastra here, that is y equals to vx, and let us see what happens now. So our dy dx is now being v plus dv. Okay. Sorry, that will be x dv dx. Yeah. So then we are getting v plus x dv dx, that is equals to vx cube by 1 plus v cube whole x. This and this will be cancelled out. So basically we will have now x dv dx, that is equals to v by 1 plus v cube minus v, and that will be v minus v to the power 4 by 1 plus v cube, and then it will be what? Our x dv dx is now equals to minus v to the power 4 1 plus. Okay. So from this we can write our dx by x will be equals to 1 plus v cube dv by v to the power 4, then minus. So from this we can write dx by x, that is equals to then minus dv by v, dv by v to the power 4 then minus dv by v. So we are basically getting then ln x, that is equals to minus v cube by sorry, just a minute. Okay, so let us make this minus this side. I think then the confusion will not appear there. Okay, so then we will have this thing here. So then from this we can write this, and that will be minus 3 here, and we will have ln v minus ln x plus c. Okay. So as we are getting this thing, from this we can write plus log v plus log x equals to c. So we are getting then minus v cube, sorry, this by 3 plus, that is log vx. As we know that our log of a plus b is equals to log ab, we are just using it here. We will get this and our v is what? We just took as our y equals to vx. So our v will be equals to y by x. So let us just put it here. So then we are getting this. So finally, our final result of it will be which is the required solution. Okay, we have just solved the case where we just took an example of homogeneous equation and we just put y equals to vx there, and we just solved the equation using y equals to vx. Okay, so when I will send the pdf of this class, so then you can understand how to do this, and we will also discuss some further questions, and then we can see how the thing goes. Okay, so the differential equation, we all know that the more the practice, we will get the correct answers, and we will also can explore all the ways how can we solve these kinds of points. Okay, so now let us take another kind of things, that is equation reducible to homogeneous equations. So let us see how can we do this type of things. So to solve the equation, basically looking like dy dx, that is equals to some a1x plus some b1y plus c1, that will be by a2x plus b2y plus c2. So from this we can write for a1 by a2 not equals to b1 by b2. We have a method to solve. Okay, so then how can we do that? We just then use, basically put our x equals to x plus h and our y equals to y plus. Then we can after that, then we can equate the constant terms of the numerator and denominator to 0 and find the values of h and k. So now, so then we just proceed how to do that. Okay, so now there are another sub case also for a1 by a2 equals to b1 by b. So then we just put a1x plus b1y equals to b, and then the equation gets reduced to variable separable form in v and x. Okay, so just let us do. So let us write a question from the first part. So our dy by dx, and let us make it simpler. So I want to give x plus y, and then let us make it x minus y, and then let us make it plus 2, and let us make it minus 2. Okay. So then basically we can easily see that our a1 by a2 is not equals to b1 by b2. Our a1 a2 b1 b2 are what? That are the coefficients of x and y here. a1 b1 a2 b2. Okay, now as we are getting this thing, how can we solve that? I just told you to just put only. Okay, so let us see what happens now. So our dy by dx is what? That is now dy by dx. Okay, so our then d big Y by d big X will look like x plus y plus then h plus k plus 2. Then that will be x minus y plus h minus k minus 3. Okay, so then we have to just choose h and k such that our this and this are 0. Okay, so how can we solve that? So we are getting two linear equations here. So let us just add these two and we will get then 2h equals to this and this will be cancelled out. We will get 1. So our h becomes half. So what will our k be? Our k will be minus 2 minus half. So that is minus 5. Right? Okay. So what are we getting now? We are just getting dy by dx is equals to then x plus y and x minus y. We just evaluated these parts to be 0, so we will get these things will be 0. So now finally we will get this. Then so now we have to use the thing which we used in the previous equation. What we will get now? This. So let us just apply here. So we will get so that is what y by x is v. We can easily see that. So I am not writing this. So finally our thing becomes x dv dx, that is equals to so then from this we can just write dx upon x is this, and we will get 1 minus v dv by 1 plus v square then. Okay, so now from this we can do what? We can do our dx by x is this and dv by this minus v dv by 1 plus v square. Okay, so we know that our derivative of v square, that is equals to 2v dv. So let us write it as 2v, then just multiply half here. So then we will get what? ln x, that is equals to then okay, just we are getting half here, so write it along. So we will get then 2x upon x, then we will get 2 by this, then dv square by 1 plus. So 2 ln x, that is equals to then 2 tan inverse v minus, we will get just a minute. So the derivative of v square plus 1 will also be this. So we can write it as log 1 plus v square, then plus, okay, plus we can write log c also, and then we will get some kind of thing. So basically let us don't mess up with constant, so let us make it c then. So then we are getting what, after calculating all the things, we are then getting ln, that will be 1 plus b square into x. So that is what we will have then. Two log x, so that will be then log x square. So we are just adding with this, so we are just multiplying these things. So basically we will get ln of sorry, that will be big X. So x square plus y square by c. Why we are getting by c? So I am just converting it to as log c. So then that will be by c. Yeah. So then that will be equals to, sorry, 2 tan inverse y upon x. Okay. So as we are getting this result, so let us go to the previous part. So when we know that our h is half and our k is minus 5 by 2. So from this we can write our general solution in the form of x minus half. Okay, so from this we basically use another thing. Let us make it x square plus y square upon c equals to e to the power 2 tan inverse y upon c. So we know what? We know that our y equals to y plus h and our x equals to a, sorry, y plus k, and our x equals to x plus h. That was written before, and our h and k has the values at half, as half and minus 5 by 2. So then we just put it in the equation. So then what are we getting now finally? So our y is, big y is y minus half, and our, sorry, our big x is x minus half, and our y is, big y is basically y plus 5 by. So let us put it in the equation. So what are we getting now? X minus half whole square plus y plus 5 by 2 whole square equals to 2c e to the power, sorry, that will be c e to the power 2 tan inverse y plus 5 by 2 by x minus. So this will be the solution of this question, where our c is an arbitrary constant. Okay, so basically what have I done in this question? I just used the thing as the translation only, where our x is equals to x plus h and y is equals to y plus k, and just put I have just put it in the equation, in the differential equation. So we will just get the constant part 0. So then we will have some results when our h and k with that will be this. So as we are solving the simultaneous linear equations, then so after solving this we will get our some values of h and k. So then as we know that the constant part is 0, then so basically our dy by dx is equals to the, that is the homogeneous equation. Then so basically we just put then y equals to bx, and after that we just calculated some differential equation stuff. So then finally we will reach in this part, and then we are just again substituting the values of h and k, and we are getting the result. Okay, understood everyone? Okay, so this was today's topic, and after that so Saurabh sir will take your class. Okay, thank you guys, thank you for joining. You may leave now.